Hi everyone, welcome to the BIM Cafe. Happy to see you again. We have more guests. This is non-stopping, and today I have the pleasure to introduce to all of you from the United States. I think she's coming from Udiksha. Welcome to the BIM Cafe.
Hey Enrique, thanks for having me.
You're welcome. I'm alright, right? You're based in Atlanta, if I'm
Yep,
not
that's
mistaken.
correct. I'm based in Atlanta,
Good, good,
Georgia.
good.
Yep.
I took a long shot there, but I think I was right. I saw that in your profile somewhere. So fantastic. Welcome on board. Just let me do a quick marketing tour around. So welcome to the Cafe. You know, we are in a YouTube channel, also in our page in LinkedIn, where these interviews will be streamed on store. So if you want to access anytime, you have the QR code to subscribe to the channel. And if you want to support our initiative as well, you can also scan this QR code and become a partner. You can see different options to help us and contribute to make this work and put the time and effort that it requires, because it's taking more and more as we get more and more popularity. So we want to keep it running, and we need the support from all the industry. So break commercial break finish. Sorry for that, Odisha.
That's fine.
Let's jump into the conversation. All right, let me just soften a bit down the music so we can hear each other properly. And I present sorry, briefly, the couple of points we're going to run today after your presentation to our audience. We're going to talk about BEM, or Building Energy Modeling, a new acronym on the business, and how automation in design can be helpful for not only energy savings but also in the future. So these two topics, which kind of are related and cover Udikcha's works and expertise, and she will be the one enlighten us today with this. So, Diksha, as I said, take the floor, introduce yourself to our audience, and tell us who you are, what you do.
Of course, yeah. Hey everyone, I'm Udiksha. I work with the research team at Cove Tool, and really my role there is to understand typical workflows of bringing in geometry to run your energy models. So, really bridging the gap of interoperability between a detailed BIM model versus running an energy model, which is what we're calling building energy model BEM. So, there's a lot of lack of data that goes into that translation, and really making sure that we're not adding to the workflow of the design team, but actually integrating within that workflow. So a lot of my work within the company is to ensure that we're creating better workflows, introducing automation into these design processes, and not having it delay the entire timeline.
Fantastic. It's important also to know that, because we're getting to the point that starting with BIM and digitalization, we want to have data management in general, to manage this data digitally, and
Correct.
sometimes we have too much data, and this is not good. It's not the much we have is not the best. No, we need to have the exact amount of data and the exact time to deliver to the right person, right? So it's important what you said, that working on the workflows to know when to deliver and how to deliver those data in which stage, not all in one model, boom, go. This is no this is not how it really works.
Right.
So, Udiksha, before we jump into the topic of building engineering, energy modeling, sorry, tell me a bit how long you've been working on Cove Tool, and what you guys do really for you develop your own applications or
Correct.
systems
Mhm.
or some routines, what you guys do.
Right, of course. So I've been with Cove Tool for almost 2 years now, and I started off as a BIM specialist, transitioning more into a technical role to really understand the product itself. So we are a software development tool. So what we do is create a tool to run your energy models, and it can be a holistic building performance analysis. We do anything from daylighting results to EUI calculations, embodied carbon calculations, and really dive deep into the layers of your building. So we're also integrating actual building products to really simulate the entire holistic building performance. And apart from that, we also, of course, have our own HVAC modeling tool as well, which is called load modeling. So we're really aiming for being the source of whole building performance analyses and tying into, like I said, the current workflows of a lot of firms that use BIM tools to run their main modeling platform.
Perfect. Let me corner you a bit, okay? I don't want to, I don't want to be pushy, but we sometimes have the perception that the software development companies, they are doing not the best of the role in terms of to the industry itself, right? Like, let me explain you. We're taking the big sample for the big names like Graphisoft for Archicad
Hmm.
or Autodesk for Revit or AutoCAD and the big names. Um, with the development of new and new modules and functions, and like they require expertise license, which are too expensive. So we are becoming like a BIM specialist or an engineer who does design in the 3D in the computer needs to have at least two or three minimum different tools
Correct.
to run the model and so on, and collect the data and calculations, etc. It's really good to keep going that way and developing a new tool for energy development, a new tool for, take your case, right? A new tool for structure and so on. Or should we let's stick with one unique software? I don't know. What do you think about this? Okay. Again, I don't want to corner you, right? But this is a good thought since you come from the software industry as well.
Of course, yeah, that's something I hear very often. It is something pretty out there where tools are being more and more isolated because they're trying to be um, hanging on to more customers to stick to that tool, which is not a great idea at all. We need
Mhm.
to expand our interoperability features and actually have a way to interact with all tools and not really actually have just one source to depend on. So, what I, of course, always go forward is to really look for all opportunities where there's interoperability. So, IFC has been a great source for us, and we've been really investigating and researching on ways to have that standard that's already been created as a source to translate geometry better, translate data from buildings better. So, like you said, there's a lot of data that goes into a building information model, or really any model that is associated with the building. There's too much, and not every stakeholder in the entire process needs to have access to everything. That's where the issue lies: too much access to
Yeah.
data or no access to data at all. So having a more streamlined workflow like IFC will be great because you can pick and choose from different classes of IFC to be part of one workflow. So yeah, I definitely agree with you. There's too many tools that want to be working isolated, and that's not what I believe.
Yeah. Fantastic. And in terms of how Tool works, do you guys receive or open work with the model on IFC, or you need to adapt the software to any other commercial system like a Revit or Archicad or I don't know?
Right. So currently we develop plugins to Revit, ArchiCAD, SketchUp, Rhino, and Grasshopper, and we also have integrations with other collaborative tools like TestFit, Procore. So we always encourage collaboration with someone else that has already built what that foundation, and we're not having to reinvent the wheel. So we always encourage that. But apart from that, we are currently working on an IFC export as well because we do see that as the future of standardization of really all models that the building industry will create.
How is it since you're based in the United States? How is it the situation of IFC in North America? Because I think in Europe we have established a more solid agreement of pushing the standards towards the IFC. And I hear from some people that in America some companies don't really even know or are aware of the file format, and they keep working and doing the interoperability inside the unique atmosphere or environment like Revit or Archicad. How is the state of the
Yeah.
IFC there?
Yeah. So the United States has not adopted IFC as the final deliverable. It is still not accepted as a construction document in the end. We are still looking for a building information model that's created from Revit, ArchiCAD, Vectorworks as well. But we are leaning in that direction towards actually adopting IFC. So I know that um, Building Smart International, they have been working really hard trying to actually enforce that standard, or really right now it's awareness. Like you said, there's not a lot of firms that actually know the benefits of using IFC. So there's the big firms that definitely do know about it and are trying to make it as part of their workflow, but that awareness still needs to be spread in the United States for sure. And that's why when I realized that Europe is usually actually using it as a final deliverable, I was really impressed by that, and something I feel like United States is on the path of getting there as well.
Okay, good to hear that. Here is not still a business as usual on terms of contractual requirements, but
Mhm.
it's getting into that. Not many countries recently, Finland uh, released their tenders, the public tenders, with the obligation of providing those tenders itself inside the FCA schema. So this is a good point. And, Scandinavian countries here, they are more the trailblazer ones. So it's
Right.
good that they start to kick the ball and roll the ball down. So let's follow them. Let's follow them. Fantastic. So Dixie, thank you so much for this quick talk at the beginning to know a bit more your work and what you do, guys, in COP2 and the situation there in North America or the United States. Let's jump into the first topic, which is BEM, or Building Energy Modeling. Well, we understand it's like building information modeling, but instead of information, we're working with the focus on the energy, right? I think
Mhm.
these two are going together. You can see a nice graphics there, which shows you how is the beam is exported from the beam model itself, right? If I'm not mistaken, and the IFC file plays a role there as well. So
Correct.
tell us a bit about what do you think about what is it this beam model and why it's important for simulation and the construction of houses or any commercial buildings as well.
Yeah, of course. So as you can see, the first point there, really buildings in terms of the entire industry, we're actually contributing towards 40% of all global carbon emissions, which is a really concerning factor. And we have so many organizations like IPCC, the the IPCC really that's conducting all these climate surveys, and even UN, of course, are releasing a lot of metrics based on how quick we need to take action on really mitigating climate change, and or really climate change is already happening. So as you can see, buildings and everything in the entire AEC industry contributes to 40%, which is a huge number, and it's pretty much the same in every country as well. It's always the large chunk of all carbon emissions from the entire globe. So really what breaks down this 40% is one, materials that go into the building. So, and that material, it's carbon emissions right from extraction. So extraction, transportation, and then finally construction of that building. There's a lot going on there and how much carbon is being emitted from this entire process. So that's one part of it. But the next part of it is, of course, operations and maintenance that goes during the building's life cycle. And that also contributes to a large chunk of that overall carbon emissions. And which is why we need to be running energy simulations for buildings to make sure that we are, of course, at a minimum, code compliant. So every state, every country has some certain energy standards that you need to meet with, so you're not creating buildings that are going to negatively impact the overall emissions. So keeping a track of what emissions the materials are going to be creating. And of course, we want to also create more livable conditions. So it's not just about controlling the carbon footprint. It's also about creating more comfortable, livable scenarios for your buildings. So really looking at metrics like daylighting, so your spatial daylight autonomy, your annual sunlight exposure, just a few metrics here that can help the final user that's going to be living in these spaces to be more comfortable in the space. So there's two parts to it, which is why running these simulations overall is beneficial to both the end user and the climate itself.
Yeah, great. I agree on all that. But this 40%, I don't know how much, if you mentioned or not, sorry for that, but I think mostly is related with the construction stage and with the transport of those materials, right? So with the building energy modeling, we are trying to save and assess the best scenario once for the maintenance for the operational
Mhm.
phase of the construction phase. So how much do you think have an impact on that 40%? So this the margin there.
So the 40% is, from what I've researched, is both transportation of those
Mhm.
materials, extraction, transportation, and even
Yeah,
erection on site. And of
yeah.
course, the building's life cycle. So there's two metrics here: operational, which is the material extraction, and then embodied from the materials and operation. So there's six stages. And really, A1 to A3, which is the material extraction itself, also accounts for quite a large chunk of that carbon emissions.
So let's say with the building energy modeling, we are tackling the part of the exploitation on the use of the building itself, like how it's going to be affected by the emissions on once the building is in place. But we cannot really measure, or can we, the previous stages of transportation and construction on this belongs to BIM, just to put a different tag on all of them.
It definitely is within the whole schema of energy modeling as well. Extraction, the
Okay.
materials definitely play a role, but like I said, there's a lot that goes in an energy model. One metric is, of course, embodied carbon, CO2 emissions. Operational carbon and embodied carbon are focused on calculating those end use materials. But apart from that, energy model includes daylighting, it includes overall energy consumption of a building. So we're tracking both what the building material extraction process is emitting, plus what is going to be consumed by the building itself during its use. So looking at lighting loads, equipment loads, your overall building system loads, so consumption plus emissions, that's your overall energy model.
Fantastic. Let's jump into the last point, sorry, the third point on the slide. I totally agree with this sentence. That is what we were discussing a bit before about the many software. So I don't know how close are you to the idea of one unique tool to rule all the digital construction world, but it doesn't need to be like that, right? But also
Hmm.
the other point of the possible scenarios, we have this like so many platforms with so many skill specific requirements, so that brings more expertise and people. And again, I add the note of licenses and buying the licenses for the different software and so on.
Hmm.
So where do you guys want to place, or what do you think is your idea to place a correct balance between not having 25 apps to calculate the emissions and anything, all the performance of a building, and not only to do it only once in one Revit or ArchiCAD or whatever?
Right, that's quite a challenging question because there's too many factors, and I feel like again it goes back to our initial conversation of why should we have just one tool based on based on what's most utilized or based on the capabilities of that tool. I know that they're having multiple tools just increases the knowledge burden on all stakeholders in this process, but it really dives deep into what sort of analyses are you trying to run? What is the goal of using a different tool? And interoperability is what I always look for. We shouldn't have multiple tools doing one thing, but there's different processes in the building industry. So information modeling can be one tool, energy modeling can be one tool, but they should all be tied together in a more seamless fashion and really interact with each other. Right now, it's just export from one, that data doesn't talk back, and then use that tool. That data doesn't go back to the original source. So having the source be more interoperable is what I would still suggest.
Well, that's totally the goal, no? Like fighting for the interoperability, and that's why IFC can play a big role there.
Absolutely.
Um, Okay, so let's see. We don't need to download any a new app or application, no? Because also as well, like I don't know what about you, but I would like to have my Revit with like thousands of endless lines of plugins as well, because if you forget what you have over there. So in a way, even though you have everything under the same software, still adds complexity of new developed plugins. But anyway, it's better than having different software for that. But good. Well, no more question from my side for the building energy modeling. It's a new concept we've been hearing also from it recently, not as long as BIM, but still for a long time. But I wanted to clarify and take this opportunity because I am a defender of not adding more acronyms to the industry, because people get scared every time they hear an acronym. You need to Google it and they, okay, what does it mean? What does it mean? So it's basically building energy modeling is how to run the simulations to understand. Let me put that in the slide because the image is very explanatory to understand how the performance of the energy itself is going to be in terms of sunlight and emissions and anyway, all the weather conditions and the proofing to reduce this 40% as Udiksha says
Right.
for the minimum possible. Great. So second and last part of the topic, this is a very interesting one from my side. Automation since the design phase. Okay, this is how we name it, how we call it, and I like this idea and the notes you shared with me prior to this interview. I really like it, saying that it's important to have it all those things thought during the design phase, because otherwise when you go to execution, you can start to automate things that quickly if they haven't been thought during the design stage. How will you see this?
Right. So the reason this is so important is because we see almost every single project working on such tight deadlines, and having changes made at any stage later than the initial phase can really prove to be very expensive, can push the deadlines, can push budgets by drastic amounts. So one thing that we really follow and keep in mind is um, the McLamy curve, which is just looking at how the traditional design workflow is, and it basically create shows you that there's a traditional design process where people tend to work a lot in the later design phases because they realize that there are changes that will improve the overall performance of the building, or they want to look at lead. Suddenly, they want to look at certifications towards the end, and that involves too many people's changes and involves integration with so many consultants, which proves to be very expensive. So automation is key here because there's a lot of factors that go into that change. You need to meet with energy codes, which is ever changing. There's so many changes being made in every single country's jurisdiction to meet with a new energy code, to meet with new standards, be net zero. And if you introduce automation in the beginning, you have that control on your hand to quickly access what changes were made through automation. So you can quickly switch out energy codes. You have access to a whole database of materials. So I'm just giving examples here of how automation can be tied in. So just material selection, energy code automation, looking at benchmarking targets for your project. Let's say you're looking at 20% reduction, 30% reduction. If you try to do that manually without automation, that will take a lot of time.
Sorry, I got my mic mute. Yeah, sorry, definitely. And as well, you mentioned something very interesting, the selection of material, for example. And to challenge that, we will need a very high, well, sorry, a big database, yeah, below that, no? Because as very good as the automation processes or the AI to select the ideal material for you is, if you don't have the whole data of the market or those generic materials, it won't be the best of the best. No, because you want to have the automation, so our brains cannot, you can just check, not like thought what is the best choice. So again, we go back to the data. How do we manage to have those databases of material? For example, you want to run this automatic selection of the perfect fit.
Correct. That's a great point you brought up. Databases is another very large chunk of integrated lack of integrated resources we have in our industry.
Yeah.
So we have a huge database for just carbon, which is the EPDs from your EC3 database. So EPDs are basically tracking all of your products that have, it's an environmental product declaration. So it's basically giving you details about the thermal performance of the product and the overall embodied carbon quantity. So that's an entire database. And not necessarily all building products will have an EPD. So now you're dealing with two different scenarios, which is I just have material data, but I don't have carbon data. So how do we integrate the two? So EC3 is a platform that continuously adds more products in their database. And that integration is what we are trying to achieve at Cove Tool. We have integrated directly with the entire EC3 database, but if a particular product does not have an EPD listed on EC3, we can also introduce those manually through our platform, or just introduce that in the automation that our system has already created. So we have three sources of data, essentially. Cost. So three parameters which most clients look for is cost. Of course, we want to not just look at sustainability because that's going to be useful for the future, but clients are very specific about cost. So cost data, embodied carbon data, and material performance data. So three databases linked together is what I feel is the ideal scenario. And creating filters based on location, based on energy code requirements, that is what I would say the end goal will be.
Yeah, fantastic. We still need to manage those three databases, which for me is still a long shot over there. And you mentioned also probably the cost is the trickiest one because there is no prices which stay longer than a couple of weeks
Exactly.
on the market too. So we really need to put AI there. I remember I read recently that the main the main issue we're going to face to implement AI intelligence, artificial intelligence into the construction industry is the lack of information that the industry has over the project, because this has been done usually paper that are not properly stored, the data is not structured, so it's very hard to feed this AI to take the proper decision after that. No, so because we, you know how we run in project in construction, we just decision after improvisation of fixing a last minute change. So
Hmm.
things are not properly recorded, and like this, the AI cannot learn how our machines operate in a construction site, right? So this is one thought apart for that. I will pick it up. I will pick it up later. So you mentioned some of the example on the automation in the science stage. I would like to link it with BIM. Okay, since we're talking here at the BIM Cafe. Any routines, I don't know, without wanting to get into technical details about Dynamo and so on, but any kind of routines that you are usually using or want to share with our spectators that really help you doing BIM. No, I remember I saw this text to BIM new platform developed recently, and it's pretty exciting. But I don't know, some tricks or thoughts you got inside your design phase that you use currently.
Right, yeah. So currently for design phases, we always go for just creating more and more massing iterations. Like we are looking to add strategies in that early design phase. So just making sure we always push our most of our customers to like start getting baseline targets. So just start getting your overall EUI targets, your energy use intensity targets in the design phase, which is massing iterations. Use tools like in Revit, I pretty much use the mass in place tool and just look at different iterations, look at your site, of course. We also integrate with test fit, which is a great way to map out what sort of possibilities are there to your overall site area, overall FAR, and number of stories that it may have. So those are typical practices. I don't have something specific with introduces Dynamo, because I typically use Dynamo when I want to work on a facade element or be more detailed and have iterations of a particular module or unit. So that's what a typical workflow would be.
Fantastic. Well, a last question from my side before we close this stage and then the interview. Let me recall the data-driven insights that we write out there on the third point. And for me, it's very important to have this data-driven strategy, because ideally, ideally, if we think about the data before we propose a design, we would need to do the redesigns or changes on site. But this is an utopia. This is a ideal world that never it will never arrive, I guess, to perfection in the construction industry. Or yes, what do you think?
Yeah, data. So, what I believe is data driven where it is necessary, because, like you said, this every project has some sort of abstractness to it. There's some sort of ideation to it, and you can't rely on just data for designing or building. Every single project is different. So, data driven where compliance is necessary, data driven where you need to comply with a certain certification is where I would always put my mind on. So, and I definitely am for it. There's so many ways to look at historical data and make decisions on the future. So all decisions based on material properties, based on thermal insulation, all of that is necessary, and it's all science and facts which the building needs to comply with. So our team is always looking for sources for any way our data can be automated, our data can be integrated with another source. So we're relying solely on facts and solely on historical empirical data.
Yeah, fantastic. Amen to all that. So, yeah, totally, totally. Well, it's very easy to talk about that in a talk show like this, but the real hard work is to make it happen in the construction, right? So this coming back to an end. No more time to for your daily routines. Good morning for you in Georgia, I guess. And thank you so much for coming here over talking about BEM, talking about the automation in design, talking about the data-driven design. Finding the balance of having like thousands of tools and integrate it all in one platform as well, very complicated, no? So wide conversation here. Thank you so much. I appreciate your time. If you want to share any more thoughts, or that's all for you as well, Elton?
Yeah, I just wanted to end with building energy model. We don't expect it to be just for experts. We want it to be as simple and as accessible, which is what the notion is outside, that it's only for experts. You need to have some sort of certifications to be, an expert in it. But no, we're trying to make it as accessible as possible.
Totally. Otherwise, the technology or the solution won't kick into the market because one thing is certain: we cannot add more complexity to the industry with technology. Well, Udiksha, thank you so much. Let me just pull up here our newsletter in LinkedIn. If you guys haven't subscribed yet, please scan the QR code and just look it on LinkedIn. It will be in our page. More than 8,000, 500 subscribers, and this interview with many others also transcribed over on the newsletter, so you can have the opportunity to hear, to listen to us, and also to read us on your screen. Thank you so much for joining. I hope you're subscribing. You get to hear, or otherwise do it right now. I appreciate your time. Udiksha, a big
Of
thank you from
course.
the community of the BIM Cafe, and wish you the best. And probably we see each other in real life. Otherwise, we see you around the online world.
Yeah, thank you so much, Enrique. This was great. Yeah, hope you have a nice day and best of luck to BIM Cafe.
Thank you so much. Thank you so much. Bye.
Bye.